Alrighty, we are going to start our next lesson, which is on correlations and lines of best fit. So let us decide if studying longer will affect Regents' grades based upon a specific set of data. Given the data below, a scattered plot has been prepared to represent the data. All that means is they took the points, they used X as your study hours and Y as the Regents' scores, and they made different points on this graph. But because it's a scattered plot, you will see that they did not connect the points. And the question said, is this a positive or a negative correlation? Well, let's see the general pattern that the points follow. We could see that the points are going up, which would mean it is a positive correlation. And then we want to know what can be drawn about this. Well, we know that as the number of hours are increasing, so are the Regents' scores. So we can say the bigger number of hours studied, the higher Regents' score. Which makes sense. The more you study, the better you're going to do. Alrighty. So, now let's take a look at what we are going to be doing today. Today we are going to continue learning about correlation, and then we are also going to learn about drawing a line of best fit. First, let's look at this Regents question. Which scatter diagram below shows the strongest positive correlation? Well, I would definitely not say C because that's going down. I didn't mean to do that. I meant to exit out. Alright, B is not going up or down. It's just a vertical line, so I'm not going to say B. And now, the one that shows the best, strongest positive correlation would be choice D, because we can see that it's almost fully forming a perfect line. So it would be choice D. Which statement about this graph is shown below is true? Well, I don't see them going up or down. It kind of looks everywhere, which means there is no correlation. So today we are going to work on finding a line of best fit, which can also be called a regression line, which could also be called a trend line. In many real-life situations, scattered plots follow patterns that are approximately linear, which means forming some type of straight line. This helps to make predictions from the data. The line of best fit estimates a straight line, which would minimize the distance between itself and where observations fall in data set. Basically, it is an educated guess about where a linear equation might fall in a set of data plotted on a scattered plot. Remember, you never connect points when making a scattered plot. So that's why we just make a line of best fit. What is the best line that would go in between these points? The line of best fit shows a trend or correlation between the different variables. Alright, so we just started by going around and asking different students what their height was and what their shoe size, and this was the data that we obtained. Now, from this data, we are able to use our calculator to create a line of best fit. You guys can't see it here because I'm doing it on my TI and Spider, but basically I would go to list and spreadsheets. I would make column A say X and column B say Y, and then I would type in this data, and then I would go to data and statistics, and I would be able to see that when I do that, it makes a line that is going upwards. Meaning, yes, is there a correlation? Yes, it's positive. So you could say that as height increases, so does shoe size. Then I went back to my list and spreadsheets. I clicked menu, statistics, stat calc, and then linear regression. And when I did that, it gave me a value for M, and it gave me a value for B, and that is how I made this equation. Alright, now it says Ms. Rappaport's height is 64 inches. Use the line of best fit to predict her shoe size. Well, height is X, so I would replace X with 64. So I would get Y equals 0.5185 times 64 minus 24.9537. And let's see what we get that. I'm doing this here on my outside calculator. 0.5185 times 64 minus 24.9537. And we get 8.2303. You would never see that when you go by shoe size, so we can just say size 8. Alright, let's look at number D. Predict the height. Ooh, so now our x is our question mark. We don't know what our x is. Predict the height of somebody who has a shoe size of 15, meaning that 15 is our y. So we have 15 equals 0.5185x minus 24.9537, which means I would have to add the 24 to both sides, leaving me with 39.9537 equals 0.5185x. And now, to get rid of that, I would divide. And for x, I get 39.9537 divided by 0.5185. I get that x is 70. Rounded, it would be 77. So we could say that the height is 77 inches. Alright, now we want to know, is there a relationship between fat grams, which we see total fat, and total calories? So again, I would go home in my calculator, go to list and spreadsheets, type this in as my x and this is my y, and then I would look at the scattered plot. When I looked at the scattered plot, I seen that it was following a positive correlation, so I said yes, there's a correlation, it's positive. Then I went back to statistics, stat calc, and linear regressions, and I found my m and my b, which allowed me to make this equation. Okay, now it says, using the equation of line of best fit, predict how many calories, which means our y is unknown, would be in a food with 50 grams of fat. So y equals 11.7313. Instead of x, I'm going to put 50 plus 193.8521. So let me go type that in. 11.7313 times 50 plus 193.8521. And I get y is equal to 780.4171. So how many calories? I'll just say 780 calories. Alright, now D is no longer asking you for the amount of calories. They told you 500 calories. They want to know how many grams of fat. So now 500 is my y. Now I'm going to subtract this 193. Subtract this 193. I get I by accident divided, I meant to subtract. 500 minus 193.8521. I get 306.1479 equals 11.7313x. Then I divide. I would get x equals rounded 26. So 26 grams of fat. Alright, now we are talking about another study. This study talks about the number of bowlers, the number of times you went bowling, and what your bowling score would be. So 1, 9, 12, 4, 15, 20, and 7. I'm currently typing this into my calculator. Then I'm going to make the B column say Y. And then my numbers are 35, 97, 108, 61, 117, 152, and 94. Alright, now I'm going to go home, go to data and statistics, make my bottom say X, make my side say Y, and I see, oh, I did that wrong, make this say Y, and make this say X. Alright, and I see it as a positive line, so it is a positive correlation, and they want to know what the equation is. So I'm going back to list and spreadsheets. I am going to click menu, stat calc, and linear regression. I'll make the X thing say X, make the Y thing say Y. I will click OK. And I'm looking for my M and my B. They want me to route to nearest thousand. So Y equals 5.6795, which is my M, then I put X, plus my B, which is 39.6845. Alright. Does the data show a correlation between the number of times bowled and a score? If so, positive or negative? Yes, positive. As you bowl more times, your score goes higher. What would you expect somebody to get on their 30th time bowling? This is telling me that x equals 30. So I would have 5.679530 plus 39.6845. Let's go type that in the calculator. 5.6795 times 30 plus 39.6845. And I get y equals 210.0695. So I could get, say, score of 210. Alright, the next one, what would you expect somebody to get on their 45th time bowling? So now we're just going to type in 45 instead. So y equals, let's go retype this in, but with 45 instead. I would get 295.262, which means score of 295. Alright, now it says, how many times would it take someone to get a score of 250? Well, let's see. We're going to make 250 equal to 5.6795x plus 39.6845. I'm not going to be able to show all my work here, but I'm going to subtract 39.6845, and then I'm going to divide by 5.6795. And I would get 37. Is that realistic? Yeah, it's realistic for somebody to bowl 37 times. That's not that hard. Alright, now we are going to move on to the second part of this lesson, which is about the correlation coefficient. We should be pretty good at picking out correlation from a scattered pop. So we should be pretty good at telling if it's positive or negative. However, looking at these visuals is subjective. Because of this, we need a mathematical strategy. The linear correlation coefficient R measures the strength of linear relationships or correlations of sample data. The correlation falls into a range of either -1 to 1. The closer it is to 1 or -1 tells us that it has a strong correlation. But the closer it is to 0, that tells us that it has no linear correlation. So let's look at this Regents question. Bella recorded data and used her graphing calculator to find the equation for the line of best fit. So when you go to linear regression, you would find an R value. She then used the correlation coefficient to determine the strength of the linear fit. Which correlation coefficient represents the strongest linear relationship, which means I need it to be close to 1 or -1. So it's not going to be this or this, and which one is closer would be 0.9. 0.8 is pretty close, but not as close as 0.9. Next one. Analysis of data from a statistical study shows a linear relationship in the data with a correlation coefficient of -0.24. Which statement best summarizes the results? There's a strong positive, definitely not. There's a strong negative. There's a moderate positive, no. There is a moderate negative. Well, I wouldn't say that it's strong because it's not really close to -1, but it is more than just being close to 0, so we would say moderate. Alright, this next one. What is the correlation coefficient of the linear data shown below to the nearest hundredth? Alright, we are basically going to need to type x and y into our calculator. This is an x value of 1 and a y value of 8. This is an x value of 2 and a y value of 8. This is 3 with a y value of 5. This is 4 with a y value of 3. This is 5 with a y value of 4. This is 6 with a y value of 1. And this is 8 with a y value of 1. So now I'm going to go type these things in. So A will be x. And I get 1, 2, 3, 4, 5, 6, 8. And then this would be y. I should have x'd everything out, so I cleared out my calculator. And I get 8, 8, 5, 3, 4, 1, 1. Now I'm going to go menu, stat, calc, linear regression. Make x, say x. I'm going to make y, say y. And then I'm going to click OK. And I get my R value of -0.93. I knew it had to be negative because my line was going down, but it wasn't going down in a 100% perfect straight line, so it is choice 3. Alright, and now let's see, what is this correlation coefficient? Well, the numbers, I can't really tell if they're going down or up because it's everywhere. So let me go type this in my calculator. I go back to list and spreadsheets, I go up to A and I put X. I put 3, 1, 4, 0, 3, 7, 5, 2. And then I put the other numbers. Alright, now I go menu, stat, stat calc, linear regressions, make X say X, make Y say Y, and then I click OK. And my R value is closest to negative 0.98. Alrighty, and that wraps up our lesson on finding the line of best fit and correlation coefficient.